Morning, everybody. How are you doing? Great. Thanks. Hope you had fun with Jeff and Scott this morning. My name is Paul Yuknewicz. I'm one of the lead program managers or product managers inside of Microsoft. I work on the product team. My team works on basically the Azure development tooling, like things like in Visual Studio, in the SDKs, Storage Explorer, all the diagnostics and debugging tools. That's what my team does. I'm really thrilled to be here with you today. I actually lived in the Philly area for about 4 years. I went to school at Haverford, so I just feel such a connection when I come here. Being here for fall too, it's awesome. Also, my alias at work is Paul Yuck. That's kind of an unfortunate thing, but it stuck with me. But I did change it in my Twitter handle, so feel free to tweet me or email me anytime. So today what I want to take you through is what I think of as the 5 services in Azure that absolutely everyone needs to know. They're kind of like the places where I start when I work with customers and partners such as yourself. What I'm going to do, I'm going to show things in C# and .NET today. However, I want you to know that this works in a whole number of languages, a whole number of SDKs, even on Windows and Linux and on Macs. So this isn't just C# kind of. So let me get to know you all just a little bit. And it's okay to raise your hands. Who's brand new to working with Azure? Like this might be some of the first. That's absolutely perfect. This is hopefully a great talk for you. Who's a bit more experienced with Azure? You've done some work with it? Okay. Some less hands, maybe 20%. Who's got a production deployment in Azure? Okay. Even down a little bit less than that, about 5%. So that's great. So some folks here have some experience. I'm going to have some new things for you, hopefully, and some tips and tricks. And for everyone here, I think I'll give you a broad overview of what I really believe absolutely everyone needs to know. So with that, so just a few things I want to do. In addition to the 5 services we should all know, I'll just make sure there's some terminology so that when I throw it out there, we're all on the same page. I want to talk about hosting environments and the ways that we host applications in Azure, which is the central thing for devs. Also, I want to look at some of the DevOps concepts because, moving to the cloud, a lot of it is about agility, which comes down to DevOps. A lot of it is about better maintainability of applications. And so I want to show some things there. And then finally, functions. So jumping straight into the terminology, one thing that I think about is just your Azure account. Here I'm showing my colleague Andrew. This is what you'd expect. When you work with Azure, there's actually a signed-in identity. This could be your corporate account. This could be your Hotmail account, your Microsoft account. And this is the thing that lets you access any number of subscriptions or plans that you pay for. It's also interesting to know that we have things like service principals. So actually machines and services themselves can have identities and accounts. Now, when you're interactively signed in with an account, you're going to have a set of subscriptions. And subscriptions are basically like billable units in Azure. And that's effectively how you pay for the computing and the data that you're working with. Next thing I think about is resources. And resources are specifically just a specific instance of any service that you're using in Azure. Kind of like, okay, when we're working on programming, there's classes, there's object instances. A resource is an actual instance of a service. So here I have a couple examples. Like we might have instances of virtual machines, Windows Server, Linux Server. Might have instances of SQL databases. We'll have instances of storage accounts. So just resources, just a super common concept in Azure. And then, as you'd expect, when you have many resources, there's things like resource groups. I kind of think of it like a namespace. It's just a way to group things together. I'm going to show you a number of tips and tricks throughout the hour where I use resource groups to keep an eye on my whole deployment unit. And I can do management actions on that. Like I could auto-scale an entire resource group or kind of organize that. I could decide if I'm going to update or patch everything in the resource group. I could even clean up and delete an entire resource group. So it just makes it easy to stay organized. And oftentimes we see customers using these to organize units of deployment. Kind of like on premises, we have things like installers, and installers are units of deployment. So here's an example. Every resource that we will create inside of a resource group. That becomes important later. I already talked about subscription, so that's the billing plan where your resources are created inside. And an account can definitely have multiple subscriptions. If you're a consultant, you'll probably have multiple subscriptions that you work with, some for each of your clients or your billable units. Also, oftentimes I see departments will keep multiple subscriptions to keep the billing boundaries separate. Or even sometimes applications have different subscriptions. Or even environments have different subscriptions. Like I see that it's a best practice to isolate your pre-production resources from your production resources. That way you have different users and roles and security and billing associated with, let's say, dev test versus production. And it just keeps unwanted accidents from happening to production. Here's an example if I have a whole bunch of. All right, so next thing I want to talk about, I'll probably talk about things like hosting services versus more of what I would think of as a PaaS service. So for hosting, the idea is it's like a host environment where you provide the code, Microsoft provides all the resources in Azure. So today, if we work on premises, we're familiar with a Windows server with an IS middleware being our hosting environment. We have services in Azure that do exactly the same thing. So like Azure App Service Web Apps is an example of a hosting environment. And that makes it possible to run things like ASP.NET apps or Tomcat apps if you work with Java, or Node.js runtime apps. And I'm going to contrast those hosting environments from things like services, what I'm calling a service. Let's say I have a storage account or a SQL account. I'm not deploying an application into it. It's just more about I'm using it to push my own data in and to take my data out. So really at that point, there's really no deployment whatsoever. It's a completely autonomous service that Microsoft in the cloud is maintaining for. So we have a number of things like that. Blob storage will be an example. Queuing and messaging will be an example. SQL will be an example. NoSQL will be an example. Any questions before I move on there? We've got a small enough group we can take questions. Straightforward. Okay, so now to have a little bit of fun, let's work on an app together. And the app that I want to focus on is an ASP.NET Core web app. Who's working with ASP.NET? A lot of hands. Who's working with .NET Core? Some hands. Right, so ASP.NET Core is our latest version. You've seen it today. It's really meant to be cloud native. It works super well in the cloud. And what my app is going to do, the app is themed around being a photo gallery. It's an app that we've all seen and an app that we've all used. And it's got a few pieces. It's got my front end and my logic, which is a web app. My user accounts are going to be backed by a SQL database. So I use my membership and my roles in there. And my actual images, because it's my on-prem app that I'm very proud of, it's worked just fine, it's using the file system. That's where all the images are. Now, there's some things we can probably imagine that would make this a little bit more cloudy, and I'm going to walk through. But right now, this is the state of the world. This is the app that I have. So this introduces the first two services that I want to think about. I want to think about a place to host that front-end web app and all the storage for it. And what I'm going to choose is Azure App Service Web Apps. It's absolutely the best starting point for any web app, any web API, anything that's really, truly stateless. Just a great place for that. It scales really well. It's available worldwide, every ring that we offer. It handles all kinds of things for you. It's really the easiest way to go. Now, there are plenty of good reasons why you might grow out of an app service web app. We'll get into some of those. So let's say I have a massively multi-layered application, lots of tiers, maybe microservices, things like that. I'm probably going to grow out of this app service web app. That's okay. And I would use something like Service Fabric, or I would use the Azure Container Service. But this is absolutely where you should start. And we run a number of our biggest properties actually on app service. Even www.azure.com or www.asp.net.com is an app service. All right, so let's do a bit of a demo here. close the good old PowerPoint. Kind of interesting having my mouse on a slope. Fall down. All right, so here we've got Visual Studio. I have the one I want. Open another instance. I'm in VS 2017, 18.4. I don't know if you've been following this, but if you get the latest versions of Visual Studio, basically all of the Azure tooling is built in now. Thanks, guys. Sorry about that. Good to go? Awesome. So this is Visual Studio 2017, and let's open our project. By the way, if you guys are comfortable and familiar with GitHub, all the code you see today I've already put on GitHub. I'm going to give you a link to it at the end. Take it home, play with it. I have the before and after of everything I'm going to show, so hopefully that'll help you. All right, so here, this is that image gallery repo that I'm working on. This represents my on-prem app. You know, and at the end of the day, it's really simple. It's kind of like a 3-tier web app that we've probably been working on for years. So I have my ASP.NET front end, core image gallery. It's MVC, so I've got a few services and things like that. Like things that can load images from the file system. I have ways I can log in. And then basically I'm going to persist everything to a very simple data model that represents an image and a little bit of metadata about it. And I'm going to run this application. Again, we're not in the cloud yet. It's doing things using IIS locally. Go. And here is my beautiful, well-polished image gallery. Clearly, I've spent a ton of time on this. But as you can see, it's kind of like the example is just supposed to be simple enough that we can talk through things. It's my 3-tier app. There's a little bit of data. The data is not in SQL. It's actually in the file system. Like if I look here, we're actually in the www root, loading images right from there. There is a bit of users and roles, so I can go ahead and log in as a user. And now I'll see the images I should see. And as myself, as Paul, I can upload an image. Let's pick something cool. Something peaceful, like a fall pasture. Okay, I'm getting my debug experience. Uploading the image, returning to the gallery. There you go. Okay, so here's my very cool image gallery. Now, let's get this thing, let's look at what it looks like to get this into the cloud. So what I'm going to do is I'm going to log into the Azure portal, which is just portal.azure.com. And because I work at Microsoft, I often get put on a dog food portal, which is a really bad idea to demo on. I'm going to do a little trick here, where I go to the public portal, which is the same one that you all get. Tricks of Hollywood. All right. So now what I'm going to do, and this is a trick that I usually charge about $10 to $20 for. Today it's free. The absolute best feature in the whole portal, I think, is this search box. Because as you create resources, and believe me, you'll create a lot of them, it gets a little bit unwieldy. But you can just start typing in substrings in the search box, and it's really pretty fast at finding things. So here, I prepared a set of resources for you to show. So this is my TechBash demo resource group. Again, just a collection of services I created. And I can see that I have an app service, which is going to be my host container for my front end. And I have a SQL server and a SQL database just using Azure SQL. And Azure SQL, let's talk about that just for a second. Azure SQL is our version of just SQL Server that's fully hosted in the cloud. It's patched, it's scaled, it's operated completely for you. You can run it as a single instance. You can run it as a farm. Installing a farm is an absolute pain, but we actually do that for you. It's even replicated. So it just takes a lot of that heavy lifting and operations out of it for you as a developer. Now you can just focus on it. So here, I have this app service, and I have the SQL, and I have some other things that I'll get into in a little bit. I just want to show you how easy it is to create that hosting environment. So let's go create another app service. We're going to hit the plus button, which is the create a resource, and let's pick web app. Do that. By default, it's going to create a new resource group, and this is a place where, you know, my tip and trick would be actually create a place to do your dev test and to play around. You can see that this morning I even created a resource group that's my Scratch resource group where I play around. I called it TechBash Scratch. And also this is a place where, you know, this is a platform as a service. So you can choose the operating system that your server is going to run on. I'm going to run it on Windows today. That'll be a good fit for my workload. But if I'm working on Linux or even containers, I can pick that as an option, and I can deploy my workload there. So, you know, whatever makes you happy, you can deploy to. In this case, I'm going to publish my code directly. But you also see, if you're into Docker and containers, you could even publish a container. The other thing, the important concept here is there's this thing called an app service plan. And let's take a look at that for a second. A plan you can think about is the actual hardware resources that you're allocating for your web app or for your web API. So let's even look at this. I can create a new plan. That is odd. I can create a new plan. We're in the East Coast today, so let's pick one in Virginia. There we go. For a lapse of reason here. But what I can see is it's giving me recommendations for the different kinds of plans I can run in. And basically I can see how much memory, how much CPU, how much compute I'll use, and basically what the cost is. Right? So here for 1 gigabyte, for all this compute, it's about $10 a month. Right? And the plans kind of go up from there. For production, I'd probably want something a bit beefier, more like a dedicated, you know, 2 gigabyte VM, and I would allocate from there. So this is a plan. It's kind of like a virtual machine, but it's more virtual than a virtual machine. It's your set of resources that you can use. The cool thing is you can change it at any time. So I'll talk about like scaling up, scaling out. Scaling out would be I can have multiple instances of the same set of resources, which is kind of like a farm. I could also do scale up, which is like getting better hardware, right? And we can all relate to this on premises. You know, maybe you want beefier hardware, so you would ask for that, but you'd have to put in a request. Or maybe you'd want more machines, so you'd ask for more machines. And you have complete control over that in Azure just by picking these different options, and you can choose it at any time. Let's stick with the plan we've got here. We'll create, and this is going to just allocate those resources in Azure. And it's actually really, it's pretty quick. Maybe it takes a minute. But I already have some for you. You don't want to wait around for us to create things. Let's go back to TechBash demo. I follow the exact same steps, and I'm going to end up with this 4-image gallery app service. We're going to drill into that. And I want to call out a few things about this that make it really nice and cloudy. Okay? The first thing is we have a set of things that you kind of need in every case. Like if I want SSL, HTTPS, or TLS, I see that I have these settings. I can just go ahead and turn it on, and I'll be using encrypted HTTPS by default, and I can pick the TLS version. I can even add my own SSL bindings and my own certificates to customize it. So this is incredibly easy. It takes the process out of adding SSL. Also, if you have custom domains and CNAMEs, you can go ahead and attach them. So you can have your favorite vanity URLs attached to the site. Now let's look at scaling. Really cool thing. So we got effectively one instance, one set of resources, almost like just one machine. If I want more than that, like I don't have to ask someone to go get me more machines. I can simply just roll the slider, let's say to 2, 5, or really whatever my requirement is. So let's actually have a little fun. Let's just go ahead and reserve 4 instances now for the server. So we're updating the configuration, and off it goes. I'll even call out here, there's auto scale. So you could use a set of metrics like, hey, how's my CPU looking? Am I starting to peg the CPU based on the load I have? Like I'm at over 80%, over 90%. I can auto scale on demand and give new instances when I hit that metric. I can also scale back. Don't want to over provision resources and waste them. So you can set up that auto scale rule based on a set of metrics like requests per second, like memory, like CPU, scale from there. You could also even create your own custom metric, which is kind of an aggregate of a few things, and you can scale based on that as well. That's scaling out. There's also scale up. And the same set of things, when we were setting up a plan, I can also just pick a better plan. I can just say, hey, I'm going to solve this kind of through DevOps, and I'm going to throw more hardware at it, and I can just do that at any time. So the cool thing is you don't have to tear anything down. You can just change the scale absolutely at any time. And that's just one of the absolute beauties of this. It's fully managed. It's fully scalable. Any questions before I go on to the next step? Yes? Mm-hmm. Yeah, so the question is, if I scale out, is there automatic load balancing? And yes, that is exactly what happens. So when I create this app service, we get basically, by default, a load balanced endpoint. So when you see this URL, it's always a load balanced endpoint. Now, whether you have 1 instance or 5 instances or 100 instances behind it, Azure will load balance that endpoint to as many resources as you have available to you. And as you scale back or scale out, the load balancer will automatically place things for you. And it'll be smart. It'll drain connections for you. It'll do all the kinds of hard stuff you have to do with load balancing. Other questions? Yes. The question is, what's the plans in supporting TLS 1.3? I don't have the roadmap for that off the top of my head. I know it's something we're thinking about. So it should be soon. We have a Azure roadmap, which I can point to at the end of the session, and we show plans for things like that and what quarter of the year they're scheduled. Okay, cool. So a few other goodies, basically, with App Service. I want to show the application settings. So one of the best practices when you enter the software as a service world is instead of having a bunch of configuration files that can have an explosion of different files for different environments. Let's say, there's dev, test, staging, production, and then I might, as a developer, I might have Paul's dev test versus Paul's staging, right? It gets pretty unwieldy. Really, the best practice is to use things like environment variables to store your settings local to the environment and just reference them by name. App Service has this pattern built in. So we have these application settings. They're per environment. They can be secured using our Key Vault, which is a really high level of security. And that way, you can just guarantee that the same application can be deployed to different environments and pick up the right environment variable. So here, I'm going to show you an example of, I have my connection string to my SQL database, and that connection string is stored actually in the environment. And so when you deploy, our tools will help you push these values into here. But also, if let's say I'm an operator or I'm DevOps, for the production environment, I'm going to override all these values, and I'm going to have values that only I know. One last thing I want to show, and I think this is a really neat thing about App Service, but I have the idea of slots. So if I'm in the mode of, let's say I want staging and I want production, I could create one slot for each, and I can even swap them as I go, which gives me that really dynamic process of DevOps. So I would definitely check that out and leverage that if you can. Okay, last questions about app service? Cool. So the other thing I want to show you is SQL. So kind of like web apps had the physical resources, which were the plan, and then I have my actual endpoint, which is my app service. In the SQL world, we have a SQL server, which is my actual resources, and again, I can pick the scale, I can pick how much I want to pay for. In this case, I picked a pretty modest plan. It's about $5 a month for SQL. Actually, not too bad. And then I have my actual database. And my database is, like you'd expect, it's the logical unit of data. And let me show you some kind of cool things here. I won't go through the process of creating a database. I mean, it's just SQL. So you can create it using a script. You can create it using an MDB file. You can create it using migrations from Entity Framework, which is what I did. But some of the cool things are, there's built-in security for this SQL database. So here I have a set of firewall rules. And I can see that actually by default, the only things that have access to these services are other Azure services. That's the only thing allowed in the firewall, plus some specific IP rules that I have here. Now you can see that my client IP address for this dev machine, for this laptop, ends with 131, and I've used the tooling to basically add a firewall rule so that my dev environment can tunnel through and connect directly to the SQL. So my SQL server is fenced by default. It's secure by default, even at a network layer. And I have the option to let some things through explicitly. And I can add a client IP at any point. Also, if you use our Visual Studio tooling and you try to connect to an Azure database, it'll just guide you and say, hey, just go ahead and add that firewall rule if you want to. Boom, off you go. Another cool thing, speaking of the Visual Studio tooling, is you could say connect with Visual Studio, and we have a little handler handshake between the portal and Visual Studio. Thank you, Edge, for prompting me. Then we'll load this in Visual Studio. Take just a second, but we've got a couple assets here. We have the Cloud Explorer, and we have the SQL Server Object Explorer. And you can see it deep linked right into the SQL Server. And this gives me some lightweight management tools that a developer needs. So I can see my tables, I can see my stored procedures. And right here, I can see already that ASP.NET, its built-in users and roles have already been created as tables, thanks to my scripts. And I can even I could drill in and I could show some table data right from inside the tool. So just to recap all that, we hit our first two services. We saw app service and SQL. And to recap it, app service is great for web apps, mobile apps, API apps, and logic apps. I will emphasize it's great for things that are stateless, meaning we don't worry too much about saving things in memory or sessions and things like that, because in the cloud, you really want to offload state to another Azure service that is a storage service. One simple way to think about that is, in the cloud, you don't want to get too attached to things. Kind of like things on a farm. You don't want to get too attached to them. You don't want to name them. In the cloud, your web app resources could go away at any time. Azure will manage giving you new resources. It'll manage load balancing things for you, but the actual physical machine could go away at any time. So if you're saving your state on that machine, you're going to be in a world of hurt. Right, so you really just want to offload all the state and all the data to another service, because that data service is going to be fully reliable and make sure that your data never goes anywhere that it should. This is fully managed. With app service, you'll never do an OS patch again. You're always on the latest patch level with app service. It's always high availability. We have the 99.99999 availability guarantee for you. It's our problem if something goes down. And you saw the scaling behavior. And then the really cool thing, we just have a bunch of tooling and diagnostics and just great things built in. We also saw a SQL database and some things that I'll just call out there. It's actually built from the same code as SQL Server. It is SQL Server. And we keep it patched, we keep it highly available, and you get all the benefits of SQL, but it's a managed service in the cloud. Now, there's just a couple differences, or I guess limitations with SQL Database, and I want to tell you those up front. It's like if on-premises we're used to editing the model or map database, or we use SQL CLR, I don't know if any of you do that, where you actually deploy managed code to the server. Those do not work today in the SQL service in Azure. However, there is an option for you. If you're in that boat, there's something called SQL Managed Instance. And SQL Managed Instance is an actual full SQL Server deployment. It's the actual same one that you would get on premises, deployed to the cloud, basically on virtual machines, managed for you, and you get 100% compatibility with that. It's a little bit more money. But if you need that actual 100% compatibility, you need full control, admin control over master and model, there's even another option for you. But if you don't have that, I would absolutely start here. You'll get more efficiencies. All right, so I mentioned that, we created resources in the cloud for the web app and for SQL, but now what I want to do, I want to modernize this app just a little bit. I want to make it a little bit more cloudy. Like I mentioned, we've been using the file system. And that's not a super great idea in the cloud, because once we scale out to multiple instances, who knows which instance or server our actual files went to, right? It could get out of control pretty quickly. So what I want to use is our third service. I want to use Azure Storage. And Azure Storage comes in a bunch of flavors. We're going to use the thing called blobs. Blobs are basically like files that have an HTTP or HTTPS addressable endpoint to the file. And it's redundant both locally. You have the option to make it geo-redundant worldwide. So like basically this data is always backed up. It's always replicated. And it's a very durable, very cheap storage. And when you have files, this is the first thing I would always look at blob storage. We also have something called the file service in storage. Files are a little bit more money. And instead of being that HTTP addressable, they're going to be system mountable. So you could actually, like a use, mount a drive. And you could mount an actual file share that's also in the cloud. So that's another option to you if you'd prefer to do that. So kind of two different options. Today we're gonna pick the recommended one, which is blob storage. And another thing I'm going to do is I'm going to add Azure Monitoring. And monitoring is built into absolutely all of the services, all of the tooling that we have. Be honest, who has who has monitoring for your current applications on-prem, right? And you know, there's some hands, there's definitely not all hands. Adding monitoring yourself is a pain, right? It's a bit of work. It might not be the first priority you have on your list. In the cloud, it's going to be pretty important, and the cool thing is it's built in. So it's not this life event anymore to add monitoring and to add diagnostics. So let's go see this in action in a demo. Right one. Okay. So I have a enhanced version of the app. I'm not going to make you watch me refactor it. But just to point out, we're now changing branches on this GitHub. We're moving from the standard branch to the what I call the end state branch, where we have a little bit more features. And the thing that I want to call out here is we've added not only a provider for file system storage, but we've added something for Azure Storage. And it's quite simple. We have SDK libraries in probably every language that you want to use. And you can connect to the storage service using your subscription. And then there's simple CRUD-like APIs to basically upload, download, delete, change ACLs, and do things like that using the storage service. So here, I can see that I take the same image object, and I'm basically going to add it asynchronously to my storage. Now let's check this out in action. So let's make this web app our startup project. We're just going to run it locally at first. Get really stressed out on my machine. Okay, so here's my beloved image gallery. And in this case, notice how the URLs look a bit different. It's still an HTTP URL, but it's talking about this storage account. Then it still looks like a file coming from that storage account. But these are actual HTTPS addressable files coming from our storage service. And so I basically offloaded all the data from my file system on IIS in an app service off into a separate service that's super high scale, super cheap to do it. And another little trick of the trade I'm doing, this app actually isn't even connected to the cloud at all. It's connected to an emulator. So with our SDKs and tools, we have a storage emulator that comes completely free. So here, you can see it right here, the Microsoft Azure Storage emulator. There's this version. There's a new version called Azurite, which is open source, if you want to see how we did this. And by the way, that one runs on Linux as well, so if you happen to use Linux. But this is a full-fledged storage emulator that just opens up some ports and simulates having storage on your local machine. And let's go through a quick demo of this. So I'm going to log in again, app. And let's go ahead and upload an image. Would be cool. That. All right, and you can see that the upload was received, and it's going to be processing. Keep in mind that a lot of things in the cloud, they're asynchronous. You want to keep that in mind. Now, if we want to visualize what just happened, what happened with that upload, we have another tool that I want to show you, which is called the Azure Storage Explorer. Completely free. My team built this. It works on Windows, Mac, and Linux, all three. And it just lets you explore all of your Azure storage, and it lets you upload and download and set security keys and do all kinds of things like that. So here you can see that I've actually connected to my local emulator as a storage account. So I could say connect to local storage, pick the emulator, or I could just pick something in my Azure subscription, either way. But I'm connected to the emulator, which is running, and I can see I have two containers. They're kind of like folders. They're kind of like logical groupings. And I have a set of images that are basically staged to be uploaded. So here's that one we literally just uploaded. Go hit the open button. Loading it from the emulator. Boom. Here's that image. And basically, it's sitting in this holding pattern in the storage account because I want to do one more thing that is particularly cloudy. But I'm going to get to that in a minute. But basically, what I want to do is I want to do some processing, and I want to add a watermark to that image. You can see I have another container where I start to add these watermarks. And keep in mind that that's a pretty compute-intensive thing. And so that's kind of a placeholder for the next demo I'm going to show you. We want to think about data and compute. Where do we put each piece of logic when we're in the cloud? Because if we do that, then we can independently scale the compute, we can independently scale the server and the data. All right, let's go to our app. Now, I also want to see maybe a little bit about the performance of this app. I want to see how healthy it is. Let's go to the portal. We're going to come back here, and we're going to see that when I use the tools, by default, we created something called Application Insights. And Application Insights is the place where you go for application monitoring. There's all kinds of monitoring we do. This is the one for applications. We'll open this up. We'll look at our deployed app in Azure, and let's just explore a little bit about what App Insights tells us. And keep in mind, I wrote 0 code to do this. I just turned on App Insights, that's all. So here's some things I'm getting. I see my failed requests. I see my response times for basic performance. I even set up some availability tests. I see that I'm at 100% availability. So my server's never gone down. Cool. One thing I would check out if I were you, check out the application map. Not just because my team built it and I'm proud of it, but also because it's kind of useful. So here, we can actually inspect the topology of your deployed app. So this is discovered dynamically through all the telemetry that's sent. And I can see that I have this core image gallery web app, and I can see that it has a dependency on SQL, and I can see my success versus failure rate. So I'm actually experiencing about a 1% failure rate. If I clicked on the red line, I get a little bit more info about that. I can see that my top failing requests were actually to the login and register. Let's actually just go peek at that. And you're going to see something that I actually did to myself this morning. This is a real bug that I in the process. I was getting some 500 errors on the register and login, and I wasn't exactly sure what was going on, but I saw that there's a 500. Let's look at one of these actual failures. And this is pretty neat. You can take any failure, and it's going to open it up in this end-to-end transaction view. This is a full distributed trace of my application. I can see that the server reported a 500 error, but the underlying reason was a SQL exception. I can see that my database commands, and I can actually see the commands that are failing. And here's basically the smoking gun to solve this mystery. I can see that the ASP.NET users table couldn't be found. And what I realized was when I was setting this app up, I created the database, I created the server, but I actually didn't migrate all of my ASP.NET users and roles tables. So it was giving me 500 errors on the server. See some heads nodding, maybe you've all yourself. But the really nice thing is I saw that error this morning. I didn't panic. I just went to App Insights. I looked at the failure. I found the exception, and I fixed myself really quick. I did a migration script, and it was off and running. So this is incredibly powerful. You don't have to overtrace or add tons of diagnostics logging statements. Just any exception, any failure is going to be captured automatically, and you have a rich set of tools to basically trace and figure it out. Another thing that I want to look at is the live metric stream, App Insight. I really love this. So if you're using ASP.NET Core 2.1, this will be here by default. Also, if you're using .NET Framework 4.x, this will be here by default. But what we're seeing here, it's a live stream of my incoming metrics and even of the trace telemetry. So let's show this in action. It's kind of like hooking up an EKG meter to our application. Before I do that, let's try to do side by side on the screen. Pick one of these is our live site, I think. Or it isn't. Go to it. Here's our live site deployed to the cloud. Clear that off. Windows key right. Put the portal on the left. I picked the right instance to actually be able to see I'm sending traffic to the site. See how these requests are spiking? You can actually see in real time happening on the site. Then if I want to think about performance, I can see what the request time was for each request. And if any of those requests are failing, it's going to come up in the request failures here, and the exceptions will come up in the. So this is incredibly powerful for both dev test and even for DevOps to inspect with real traffic what's going on, understand the causality of things super quick, and kind of pinpoint observability-wise things that you want to fix. Let's drill into performance, because one thing I'm noticing is some of these requests are just too long. I'm probably not forcing that to happen here. Let's do something a little beefier. Let's upload an image. And that one just took 4 seconds. Out. Another one. By the way, nothing keeps you honest like doing a real demo with live metrics. No faking. That one was quite a bit faster. Notice that dip. So one thing that I'm not super satisfied with is I'm seeing that some operations are slow. I mean, some of my customers are getting, under normal circumstances, slow requests. I want to do something about that. So looking at all operations. But I can focus on all the operations or which one. I can see that my slowest requests are actually things that hit the database. Also, this uploaded an let's drill into. Also, by the way, really into the first 5%. Let's look at these. I'm actually going to take some examples. Now, I would usually hypothesize always SQL. Slowness, always SQL. It's got to be SQL. Something's wrong there. Mythbuster here is actually showing me, because I have this space, that a lot of the time is actually spent in. But so that totally invalidated my hypothesis. This is actually saying it's spending way too much time on, right? And that will kind of bring me to the last things I want to do. I want to offload some of my compute to another service. Talked about how, as a part of pushing or posting to my index with the upload, I'm adding things like a watermark, right? And so that's chewing up my CPU cycles on my web server. And it's basically making everyone's experience a bit, right? Imagine that you've got some people uploading, but you're not uploading. You're just viewing the page. You're downloading. You're being affected on the CPU by people who are uploading, right, and creating these watermarks. So that's kind of a classic example of noisy neighbors. It's a great use case for the cloud. cloud can infinitely scale anything that's hard work. So that brings me to kind of my last service that I want to focus on, service number 5, which is functions. Here. Now, a function at the simplest level is just any old function. In this case, it's written in C#. I think of it like an event handler. So functions let you do event-driven programming off of cloud Azure resources. So in this case, whenever a blob gets uploaded to blob storage, I can see I'm watching this. Whenever that happens, I want to trigger this event, and I want to do some heavy lifting in my code. In this case, the heavy lifting's not crazy, right? I have this watermarker library that does watermarks, call it, passing in. It's not a big deal what it's doing, but the interesting thing is, from a CPU consumption perspective, it is kind of a big thing. We saw the actual data chewing up our CPU. So I'm going to use a function to do this compute instead, and I'm going to just have my front end, it's just going to upload images. That's all it's going to do. My function's going to be listening for that event that something was uploaded. It's going to do the heavy lifting, and it's going to hand back a watermarked image in another blob container. I'm just going to have my app point to that watermarked. We got an example of that, right? We looked in Storage Explorer. I can see that uploads now always go to the images folder, and when you're viewing your gallery, downloads always come from this watermarked. A pretty simple architecture. For those of us who have done servers, like Windows services with queues, this is no different than I've dispatched some work to a queue. Some other service is sitting there listening, doing work, and when it's done, have your front end just from same exact pattern. Right, so I have my simple function, and let's even look at just how easy it is to create a function. So I'll take my original project, add a new project, pick cloud, and I'm going to pick Azure Functions. And I mentioned that this is event-driven programming. So we have a set of stock services and events that you can respond to, right? So I could here trigger off of blobs. I can trigger off of all kinds of things. If I use Cosmos DB full, I can trigger off of that. If I have IoT messages, off of that, service bus messages, timers. I could use something like I could even have a webhook that could trigger a function. There's just all kinds of possibilities. Blob trigger. And you can see that by default, our tooling makes it easy because we'll use that storage emulator by default to back this. You could also just go ahead and pick a storage. I'm actually kind of curious, who here would want to work locally in a dev test environment? Who would prefer to work against the cloud? I'll have to follow up with you. Always interesting. There's people in Redmond who believe everyone should do everything in the cloud, but I believe it's quick. But as you can see, when I created that project, it just scaffolded a function already wired up through this attribute. Listen to a particular blob, and off you go. Just incredibly easy to make functions. So in this working project, a couple tips and tricks. But I can set my startup project as my function. I can go ahead and F5 that. And we automatically know how to spawn a function. It's basically like a console. Host your function in the console app, get the console output, and actually you can see it was looking at that image, already uploaded to that images folder, did the processing, logging. Now I should be able to go back to I can see that the image that was in this holding bay got processed. I can see just now live. Cool, so that gives you an example of functions. Actually, one more tip and trick. Also free. Maybe you've done this places. If you have a multi-tier app, so here I have my front end, I have my Azure Functions backend, customize the properties, create multiple startup projects. Let's start the function, start the core image gallery. I want to start the function. Now when I hit F5, it'll start both the IIS app and the test this. Capstone here. So we saw, just to recap everything, we saw Azure Storage, blobs, files, well. Also options for more tabular. And there's automatic replication. Even less expensive plans for things like cold storage. We saw Azure monitoring. We saw that it was built in. We saw that it was automatically monitoring resources, CPU, memory, request rates, perf, failures. But it even got to the code level with application insights, showing us requests, showing us distributed trace. And we do some kind of fancy things in .NET where we add correlation. I think Scott Hunter didn't get to show it this morning, but there's even a next step after this. There's a thing called a snapshot debugger that will debug in production with blocking a. All these tools are available off of this. And we last showed that we added an Azure function. The Azure function is going to do heavy lifting. And we think of Azure Functions as serverless. Like, this is a consumption-based service by default. So you're only using resources for the amount of time that and no more. So it makes functions very desirable because they're very inexpensive, pay as you go, and it scales so incredibly well because we can just throw resources from Azure at the problem only. Now, if you have something that's very chatty, it's working all the time, we have another plan that's basically a dedicated plan where that function's always warm, it's always running, it's ready to go. And then at that point, it's basically like having a web API and an app service. You're reserving a whole set of resources. We saw that it was event-driven, so it's really good for a worker or a job because you can trigger an action off of a timer or based on an event and work. Then at that point, it's just coding as usual. And it's really, really good just to drive this home. CPU-intensive things, memory-intensive things, put those in functions and really take the pressure off of your front end. There's a bunch of services we're not going to cover today, but you might just want to take a look at them afterwards. If you're interested in containers, we have two container services. One that's more Linux-oriented and Kubernetes-oriented, and one that's very Windows-oriented, Service Fabric Mesh. We also have Linux offerings if you're interested in that. Other things I would mention, I whispered Key Vault before. Key Vault lets you securely store secrets. It's encrypted at rest. Only the runtime process can get at these things. It's authenticated, super cool. And we have a set of messaging services that go beyond what I showed you. So if you have a high degree of messaging and you want to isolate topics, we talked about managed instance. If you want to do object persistence and document persistence instead of relational databases, we have Cosmos. In Active Directory, using Active Directory on-prem, we have a cloud-based version in Azure. So with that, I will summarize. You saw the 5 services. Please check them out. Please go get the source code. Here's an easy URL. I'd be happy to make all the slides available to you offline. You can also check out some additional guidance that we have on our blog, our docs, and we even just created this new dev center for migration, going from on-premises to cloud. I'd love you to check that out and tell me. So with that said, thank you, everybody. Thanks for spending the hour. Take care.